Welcome to this quick control tutorial video. My name is Noel Gutierrez and I'm the support engineer at QuickServer Controls. In this video, I'll show you how you can expand your program. First, I'll show you where you can find existing programs that are included with QuickControl. Then, I'll build a program showing common programming techniques. When QuickControl is installed, it includes a folder called QCI Examples, which contains various program examples. To view the folder, we'll go to File, Open. We'll go to My Computer and your local disk, commonly the C drive. Then we go to Program Files, QuickControl, then QCI Examples. Here we have various program examples that are categorized by topics. Reviewing these examples is a great way of learning QuickControl. All these examples can be cut and pasted into your new or existing applications. The analog inputs folder includes an example of reading an analog input. We can also read the power supply voltage as well as the temperature of the controller. The applications folder includes an example where we can modify the velocity and acceleration on the fly. There's also a record and playback example where we can record the position of the motor to non-volatile memory and then play that back later. On the CAN folder includes examples for controllers that are CAN enabled, where they can be programmed to share their internal status, they can share their I/O status, and the contents of their data registers. The data registers folder includes several examples of how to modify your data registers. The electronic gearing and camming folder includes examples on following a cam table. We can also follow an external A and B quadrature encoder, as well as step and direction signals. The homing routines folder includes examples on how to home against a hard stop. We can home against the sensor, as well as home against the internal encoder index pulse. The input modes folder includes examples on how to use an analog input to control position, velocity, and torque. The motor shutdown folder includes examples of how to recover from a kill motor fault. Move basic folder includes examples of using different move commands. Multitask has examples of the controller executing commands in the background while the controller is performing a motion command. In multi-thread, we can run two programs simultaneously. Outputs includes examples on how to set an output either high or low. We can also program a trigger that toggles an output depending on the motor position. Profile moves includes examples of how to generate dynamic motion profiles. Program flow, the examples show how to control the flow or control the logic of a program. Stop and move folder includes examples on stopping a move under different scenarios. And using inputs for move selection, there's examples on using inputs to call specific programs or specific moves. We'll start off by selecting an existing program under the QCI Examples folder, Moves Basic folder, and I'll select Move Forward and Back. It's a simple program that moves the motor between two positions. With this jump to loop, it's an unconditional loop, so it'll repeat those two commands indefinitely. In this application, I want to repeat the same two move commands 5 times. So what I'll do is I'll add a for next loop. So I'll click on line 2, and I'll click Insert to add a line above line 2. And under the Flow tab, I'll select 4. For my loop register, I'll click the loop register button and select register 30. And I'll type in loop, I'll rename it to loop counter. Click OK. My initial value, I want a initial value of 1, my final value of 5. This will repeat this 5 times with an increment of 1. So now to close the for loop, I need a next command. So I'll click on line 4. click the Add button to add the command below line 4. And under the Flow tab, I'll select the next command. With the next command, it'll automatically look for the 4 command, and it sees it on line 2. So it'll repeat everything that's between the 4 and the next command 5 times. So I'll go ahead and delete this unconditional jump. We don't need it. And I'll double click on this loop label. We don't need that either. And I'll go ahead and download this program. We can see our motor position here on the right as the motor moves back and forth. So what I'll do is I'll go to Tools, Register Watch, and I'll add register 30 so we can see our loop counter increment. Starts off with 0. I'll click Restart again. So the last value is 6, and with the value of 6, it exits the for next loop. Now I'll add a second program using a different loop method. So to add a second program, we go to Programs, New Program. I'll rename the program to second loop. And I'll start off by adding a WRP. It's a register write command under the Register tab. So I'll select WRP. I'll select register 31. I'll rename it to second loop counter. Click OK and OK. And I'll write a 5. And I want to repeat this loop 5 times. Then I'll add the commands I want to repeat. So I'll just use a simple move command, MRT. Move 1,000 counts. Ramp time of 100 milliseconds. Total time of 1,000 milliseconds. And so I'll repeat that same command. So I'll copy, Control C, Control V, paste. So I'll move 1,000, and then I'll move negative 1,000 counts. So I want to be able to repeat those 2 commands 5 times. So then the next command is to then decrement our second loop counter, register 31. So we'll go under the Register tab, select Calculation, and I'll select register 31, our second loop counter, and the operation is decrement. So it'll subtract 1 each time it loops through. And then the last command is a jump command. So we'll go to Flow, Jump. Now I want to jump to a label, so I'll enter a new label of loop. And I want to jump to this first MRT, so I'll click on the label column on the first MRT and start typing loop. Now, I want to be able to jump to this loop command while register 31 is positive. So to do that, I'll double click the jump command, click the conditions button, and I'll set a condition of if last calculation was positive to true. So it's, with this condition, it will look at the previous command, the previous calculation, which is this CLC, and if register 31 is still positive, it will jump back to the loop and repeat. Once it runs 5 cycles, register 31 will equal 0, and which will cause this condition to be false. So it will end the loop command. So I currently have 2 programs, program 0 and program 1. I'll go back to program 0. I'll rename that to first loop under programs, program details. So now we have 2 different programs. So now I want to be able to select either program 0 or program 1 using an input. To do that, I'll use a third program. I'll add a third program to it. So we'll go to Programs, New Program. I'll give this a name of main, and I'll add a jump command under the flow. So jump on input. So I want to jump to a first loop. So I add a first loop label, and I'll give it a condition when IO1 is low, false. Click OK and OK. And I'll add another jump on input, second loop, and I'll give it a condition of when IO2 is low. So it will check the first two IO1 and IO2. If none of these conditions are met, what I want to do is jump back to the first command and keep checking. So I'll add a third jump command, and I'll type in loop. This will be an unconditional jump, so there's no conditions. So now if IO1 is false, I then want to jump to an LRP command. It's a load and run program. So I'll double click LRP, and then I'll select my first loop program, click OK, and for the label I'll start typing in first loop. I'll then add a second LRP command. I'll select the second loop, and I'll type in second loop. Now, with main program, it's actually the third program in this entire QCP file. When I download the program, what happens is it'll first run the first loop 0 program, and if we go to program details, we see that first loop is stored at memory location 512, which is our default starting location for an application. So what I want is this main program to run first. So I'll select main 2. I'll go to programs, program details, and the program index I want to set it to 0, so that it moves up to the first program. So now it's set to 0. So if we go to programs, program details, we see that the memory location is set to 512. So this will be the first program that runs. So I'll go ahead and download this program. Okay, the program's downloaded. I'll go ahead and add register loop 31. And up here under the device status monitor, we can see the IO states. They're currently set high, so they're displayed with a green box. I'll go ahead and check the debug button so we can see where the program is running, and we can see that it's running between lines 2 and 4. Currently, both IO1 and 2 are high, so I'll go ahead and turn IO1 low. Should jump to the first loop program. There we go. So now the program ended. Now what I want to do is be able to jump back after it runs the first loop or the second loop program. I want to jump back to the main loop, the main program. So what I'll do is at the end of the first loop program, I'll add a load and run program command, and I'll select main, and I'll do the same for second loop. I'll click the last command, click add an LRP, select main. So now once it runs through the loop, it'll jump back to the main program. So I'll go ahead and download, restart. I'll click debug. My IO1 was low on startup, on power up, so what it's doing is it's continuously running to the first loop. If I hit my switch high, it runs it once, or if I hit it low and it stays low, it'll keep running the program until I hit IO1 back high. Now I'll hit IO2 low. And you can see the second loop program runs. So I'll go ahead and stop the program. And I'll uncheck debug. And one last thing I want to change to the program is add a condition where it'll only run once per I/O cycle. So if the I/O is held low, I want to be able to have the I/O turn back high before running a second cycle. So to do that, I'll add a command after the next. Under the flow, I'll select the wait on bit state. So I'll wait for IO1 to go back high. So I'll click OK. Then I'll go to the second loop and add a similar command. I'll click add, wait on bit state. And for the second loop command, I want IO2 to go back high. So now I'll download restart. Both IOs are currently high. So I click IO1 low. And you can see that it's only running once, so it's waiting for IO1 to go back high before jumping back to main program. So I'll set it back to high. So now we're back at main. So I'll test IO2. Waits for IO2 to go back high. So I'll set it high. Then we jump back to main. Now this concludes this tutorial video. For more information, you can visit our website at quickservercontrols.com, or you can also email us at support@quickservercontrols.com.